Okay, this one is the last yesterday's problem. Hamiltonian H is equal to how much? 1 by 2 px minus ay bracket square plus 1 by 2 py plus py minus bx bracket square. And these two quantity are conserved. This one is two quantity are conserved. Yes or no? This one is conserved means these two quantity are conserved means yes. Any quantity is conserved or constant. Any quantity is conserved or constant. Its first derivative is equal to how much? 0. Its first derivative is equal to how much? 0. Means d upon dt px minus 3y is equal to how much? 0. First one. And the second one d upon dt py plus 2x bracket is equal to how much? 0. Why? Because these two quantities are conserved. These two quantities are conserved. D upon dt px minus 3y is equal to 0 and d upon dt py plus 2x is equal to how much? 0. Okay. Now take the derivative of this one. Then this become px dot minus 3y dot is equal to how much? 0. Is equal to how much? 0. This one is the first equation. This is first equation. And what is the second equation? Take the derivative of this one. Then this become py dot plus 2x dot is equal to 0. 2x dot is equal to how much? 0. Okay. But we know that px dot is equal to how much? Px dot is equal to, yes, px dot minus double h upon double x minus double h upon double x is equal to minus, yes, px minus ay bracket square double h upon double x. Okay, this is the second one. Yes,
minus b
minus py minus bx into how much? Minus b. Okay, these two to get cancelled. This is equal to how much? Simply b py minus bx. This is the value of px dot. Got it? Next, py dot
minus double h by double
py dot is equal to how much? Py dot is equal to minus double h upon double y. Okay, this is equal to how much? Py minus bx. 2 times 2 to get cancelled. Okay, this is equal to how much? Minus px minus ay into how much? Minus a into minus a. Minus minus become plus. Means py is equal to this minus minus become plus. Px minus ay. Got it? Next, we can find out the px dot value, py dot value. Next, our aim to finding the y dot value and x dot value. X dot is equal to Hamiltonian equation. X dot double h upon double px is equal to x dot is equal to double h upon double px is equal to else. To get cancel px minus ay. Okay, and what is the y dot value? Y dot is equal to double h upon double py is equal to how much? Double h upon double py minus ax. Okay, next, suppose you can substitute this value in equation number 1 and 2. Suppose this equation number is 1, this equation number is 2. Suppose equation number 1 and equation number 2. We can substitute the px dot and y dot value in equation number 1. We can substitute which value? Py dot and px dot and y dot value in equation number 1. equation number 1. Okay. What is the equation number 1? Px dot minus 3y dot is equal to 0. What is the Px dot value? Px dot is equal to b py minus bx. Py minus bx. Okay. Minus 3. What is the y dot value? Y dot. Y dot. Py minus x. 1 minute. Px dot is equal to how much? Double h upon double x. Px dot is equal to py minus bx. Okay. And second one, minus 3 y dot. Y dot is equal to py minus x. Py minus ax is equal to 0. Py minus ax is equal to 0. Okay. X dot py minus bx
minus dx
minus bx. Py minus bx is yes. Next. Next. From these two equations, we can take common out. From these two equations, we can take common out. Py minus bx into b minus 3 into b minus 3. AB is equal to 0 implies that AB is equal to 0 implies that A is equal to 0 or B is equal to 0. But Py minus bx is not equal to 0 implies that b minus 3 is equal to 0. B minus 3 is equal to 0 implies that B is equal to how much? Implies that B is equal to how much? 3. B is equal to 3. Same. We can substitute the py dot plus 2x dot value. Py dot. What is py dot value? Py dot is a px minus ay. Px minus ay. What is the x dot value? X dot value is equal to how much? X dot px minus ay. X dot is equal to how much? Px minus ay plus
py minus x.
X dot
py minus x.
Okay. रिवर्स झाली आपल्याकडून व्हॅल्यू नाही x dot.
सर ऊपर वाला इक्वेशन भी रॉन्ग है वहाँ py minus ax.
दवा px. Okay. P x minus ay. Okay. A px minus ay and y dot is equal to how much? Y dot is equal to py minus bx. Px minus ay is equal to how much? 0. Again, from these two equations, we can take common out. Px minus ay. Px minus ay common out. Inside, a plus 2 is equal to how much? 0. Px minus ay is not equal to 0. Implies that a plus 2 is equal to 0. A plus 2 is equal to 0 means a is equal to how much? Minus 2. A is equal to minus 2. We can substitute a and b value is equal to this one. Then we can substitute this value in this equation. Then these two quantity become 0. Yes or no? Or time derivative of this function is equal to how much? 0. What is the a and b value? A is equal to minus 2 and b is equal to 3. Yes, any doubt in this case? We know that this quantity is conserved. This quantity is conserved. Take the first derivative is equal to how much? 0. First derivative 0. And next we can substitute the Hamiltonian equation values. We can substitute the Hamiltonian equation values. We get A and B value. Next, H is equal to P square upon 2 minus 1 upon Q square minus 1 upon Q square minus 1 upon 2Q square. Okay. And we can check PQ upon 2 plus HT is conserved or not conserved. PQ upon 2 plus HT is conserved or not. Yes. D upon dt. D upon dt. PQ upon 2 plus HT. Yes or no? D upon dt. PQ upon 2 plus HT. We need to come. Next problem आहे यामध्ये चेक करायचे. Check it. This one is conserved or not. Check it. This quantity is conserved or not.
Okay, the PQ by H. Take us, sir. PQ by 2 plus HT conserved. Okay.
Yes. PQ upon 2 plus HT. PQ upon 2 plus HT. Yes. What is the derivative of this one? 1 by 2. PQ derivative with respect to time.
P dot Q plus PQ dot.
P dot Q plus PQ dot plus EH. Yes or no? We can use the Hamiltonian equation. Yes, Hamiltonian equation. P dot is equal to P dot WH upon
Minus of that budget.
minus WH upon minus WH upon WQ minus WH upon WQ. Yes, plus minus
Minus 2 upon QQ.
minus 1 upon QQ. Yes or no? Or what is the value of Q dot? Q dot is equal to WH upon WP. WH upon WP. Yes, WH upon WP is equal to P. To get cancel. Okay, next. We can substitute this value in this equation. Then we getting 1 by 2. 1 by 2. Yes. P dot. P dot.
1 upon QQ.
P into. Okay. P dot minus 1 upon QQ into Q plus P into Q dot. P into Q dot. P plus H. H is equal to how much? P square by 2 minus 1 upon 2Q square minus 1 upon 2Q square. 1Q get cancel. Okay, 1Q get cancel. 1 by 2 inside minus 1 upon Q square plus P square by 2 minus 1 upon 2Q square minus 1 upon 2Q square. 1 by 2 multiplied inside, then this quantity conserved, not conserved. Yes or no? We can multiply it inside, then this become minus 1 by 2 Q square plus P square by 2 plus P square by 2 minus 1 by 2 Q square. 0 non-zero. minus 1 by 2 multiplied inside, then this become minus 1 upon 2q square plus p square by 2 plus p square by 2 minus 1 upon 2q square. 0 non-zero. 0 miss 0 non-zero. Okay, हाँ ये minus 2q minus 2q.
2h not 2h.
This is equal to how much? P square 1 by 2 plus 1 by 2 is 1. Okay, means p square
minus 1 upon q square.
Minus 1 upon q square. This is equal to 0 non-zero. This is not equal to 0. Is not equal to 0. Not conserved. Which quantity is not conserved? PQ upon 2 plus ST is not conserved. Is not conserved. Okay, last problem they are already given. This quantity is conserved. Hence we can take RHS is equal to how much? D upon dt something is equal to 0. Okay. Here we need to check this quantity is conserved or not. Hence we can take d upon dt. We getting 0. We can say this one is conserved. This is equal to not getting 0. We can say this one is not a conserved quantity. Yes, any doubt in this case?
No sir. Easy sir हे problem. सर असा असतो का एखादा तरी?
नाही 5 मार्काचे प्रॉब्लेम आहेत सगळे.
नाही पण नेट मध्ये असतोच का म्हणजे असा?
हा येतो ना. उलट हाच डिफिकल्ट आहे प्रॉब्लेम कंपॅरेटिव्हली अदर. कंपॅरेटिव्हली अदर हाच प्रॉब्लेम डिफिकल्ट आहे.
उलट हा सर इझी बरा आहे म्हणजे पटकन होतो.
नाही त्यासाठी मेथड लक्षात आली पाहिजे इनिशियल वन. म्हणजे त्या आधी इक्वेशन तो सॉल्व्ह करायला पाहिजे. नेक्स्ट प्रॉब्लेम. L is equal to okay. L is equal to 1 by 2 m x dot square plus y dot square plus k 2x plus 3y. 2x plus 3y. Okay. And we need to conserve which of the following option is correct one. Which of the following quantity is conserved? Direct upon give px minus 2py minus 3px. 2py minus 3px. 2py minus 3x. Okay. They are given another options also. Total 4 options. We can check this one option. 2py minus 3px. 2py minus 3px. Yes. Now this quantity is conserved, not conserved.
टाइम डेरिवेटिव्ह काढावा लागेल.
This quantity is conserved or not conserved? 4 ऑप्शन आहे त्यातला एकच ऑप्शन आपण चूज करतोय म्हणजे कॉन्झर्व्ड आहे की नाहीये. येस ही कॉन्झर्व्ड आहे म्हणूनच हा ऑप्शन आपण चूज करतोय. लक्षात येते एक्झाम मध्ये तुम्हाला सॉल्व्ह करावं लागतील 4 ऑप्शन्स पण आता इथं हा कॉन्झर्व्डच आहे. लक्षात आहे. हा बोला. d upon dt 2py dot minus 3px 2py minus 3px is equal to how much? Is equal to 0. Take derivative, then this become dpy upon dt minus 3 dpx upon dt is equal to 0. dpy upon dt minus 3 dpx upon dt is equal to 0. Okay. dpy upon dt is nothing but py dot minus 3px dot is equal to how much? 0. This is equal to 0. Here we can study the Lagrangian, not Hamiltonian. Okay. In a Lagrangian case, what is the value of P generalized momenta derivative? Generalized momenta derivative. We know that equation of motion. Equation of motion d upon dt double L upon double x dot minus double L upon double x is equal to how much? 0. Is equal to how much? 0. Double L upon double x dot is nothing but
px.
Yes or no? Double L upon double x is nothing but px. Got it? Double L upon double x dot is equal to how much? Double L upon double x dot. Double L upon double x dot.
px.
mx dot.
Okay. lx dot.
Yes or no? Or we can check here. 1 minute. d upon dt. Yes, to py. Py means generalized momenta. What is the generalized momenta value? Generalized momenta py is equal to double L upon double y dot. Double L upon double y dot. Means this is m y dot. Got it? Py is nothing but double L upon double y dot minus 3 px minus 3 px double L upon double x dot. Means this is mx dot. Yes or no? mx dot. आता आपण चेक करतो मीन्स RHS is not equal to 0 initial one. Here we can take m is common out. Then 2 dy dot upon dt minus dx dot upon dt is equal to how much? This is not equal to 0. Okay. We cannot find out this is equal to 0 or not. dy dot upon dt is nothing but dy dot upon dt y double dot into x double dot illa. First one is y dot. Again we can take one derivative, we getting double dot. Means 2y double dot minus 3x double dot. Okay. Next, our aim to finding the what is the x double dot value and y double dot value. Equation of motion d upon dt double upon double x dot minus double upon double x is equal to how much? 0. Is equal to how much? 0. Double upon double x dot is equal to mx dot. Okay. This can be written as mx double dot minus, or this is equal to how much? Double upon double x. Double upon double x. Double upon double x. This part is equal to 0. This is equal to how much? 2k. Okay. Means x double dot is equal to 2k upon. Okay. Similarly, y double dot is equal to. Yes, double upon double y. 3k upon m. Yes or no? Y double dot is equal to double upon double y. 3y. 3. And m multiplied here. This k is outside. Means what is the x double dot and y double dot value? This one. Then m 2 y double dot. 3k upon m minus 3 x double dot 2k upon m. 3 into 2 6 m 6k upon m minus 6k upon m. 6k upon m minus 6k upon m.
0.
This is equal to how much? 0. Implies that. This is equal to 0. Implies that. minus 3px is conserved. This also need problem, okay? This quantity is conserved.
सर मग असं सगळं चार ऑप्शन मध्ये असेल तर सगळ्यांना चारीला चेक करायचं का?
Yes.
सपोज पहिले 3 ला नाही आलं तर किती वेळ जाईल? याच्यात भरपूर वेळ जाईल ना.
हो, लेंथी क्वेश्चन आहे हा.
ट्रिक वगैरे नाही का काही मग?
नाही असं ट्रिक, हीच ट्रिक आहे. कॉन्झर्वेटिव्ह टाइम पार्ट इज इक्वल टू हाऊ मच 0. मी सांगितलं नाही, यासाठी 3-4 मेथड्स आहेत, पण दिस वन इज द सिम्पलेस्ट वन एज कम्पेअर्ड टू दिस वन. रिमेनिंग ऑल मेथड्स. बाकी तर खूप लेंथी प्रोसेस आहे आणि ते कंपेअर करणे थोडं डिफिकल्ट आहे. ओके, नेक्स्ट ऑसिलेशन. दे आर ऑसिलेशन. ओके, आता या केसमध्ये आपल्याला फ्रिक्वेन्सी फाइंड आउट करायची असते. ओके, फ्रिक्वेन्सी. सपोज वी कॅन टेक द लॅग्रेंजियन L इज इक्वल टू 1/2 m. Suppose x dot square plus y dot square minus kxy minus kxy. Okay. Now we can find out what is the frequency for this case. What is the frequency for this case? सगळ्यात महत्त्वाचं या केसमध्ये फ्रिक्वेन्सी फाइंड आउट करायची असते आपल्याला. Now here we can use the matrix method. Matrix method means write down matrix for kinetic energy, matrix for potential energy, write down the secular equation, here write down kinetic matrix method using matrix method. Okay, using matrix method. Number 1, write down the matrix of kinetic energy. T is equal to 1/2 m x dot square plus y dot square. Okay, T for these two parts, x dot y dot, write down 1/2, take common out, x dot y dot. Here also we can write down x dot y dot. X dot into x dot. Okay, x dot into x dot. X dot into x dot. X dot into x dot.
X dot square.
X dot square. X dot into x dot, x dot square. What is the coefficient of x dot square?
X dot is square m.
X dot square coefficient is 1/2 m or m/2. Yes or no? What is the x dot y dot coefficient? Here x dot y dot coefficient 0. Absent means 0. Y dot x dot
0.
Y dot x dot. Next y dot
0. m by 2.
Okay. This is the kinetic energy matrix, and this is can be written as simply m/2 0 0 m/2. Got it? 0 m/2. This is the kinetic energy part. Next, potential energy. Here Lagrangian, we know that L is equal to how much? T minus V. Means what is the value of V? What is the value of V?
Half kxy.
half kxy. Positive, negative?
Positive.
Positive. Don't take negative,
Positive.
okay? Because here is a negative. Either the plus असेल, at that time you can take the minus. Okay? Because L is equal to T minus V. Write down the matrix for potential energy. Potential energy variables x and y. X and y. Here write down x. Here write down y. X and y. X into x.
X square.
X square. X square coefficient
0.
0. But always write down in symmetric manner. Okay. Symmetric lines कधी. Suppose a plus b bracket square is equal to how much? A plus b bracket square.
A square plus
B square plus a square plus b square plus
2ab.
2ab. Don't write down here 2ab. Here write down ab plus ba. ab plus ba. Means here is a xy can be written as 1 by 2. 1 by 2 k xy by 2 plus 1 by 2 k xy by 2. Got it? xy by 2. X square coefficient. X square coefficient 0. Xy coefficient
XY coefficient k by 2.
k by 2. K by 2. Yx coefficient.
K by 4 na sir.
Okay, 4.
Yes sir.
K
K by 4 na.
yx upon 4. Yx coefficient
K by 4.
k by 4. Y square
K by
coefficient.
4.
Y square coefficient
0.
means potential V is equal to how much?
V
0.
equal to matrix
K by 4.
0, 4, K by 4, 0.
0. Next, write down the secular equation. Secular equation. Secular equation. What is the secular equation? V minus omega square t. V minus
Equal to 0.
omega square t is equal to how much? 0.
0.
V minus omega square t is equal to 0. What is the value of V here? V. V means 0. K by 4. K by 4, 0. Minus. Sorry. 0, K by 4, K by 4. Minus. Minus omega square.
Omega is square.
M.
Omega square.
0.
M by 2, 0. M by 2, 0.
Okay. Then this is equal to how much then? Total matrix. Minus m omega square upon 2 k by 4 k by 4 minus m omega square by 2 minus m omega square by 2 is equal to how much?
0.
Is equal to 0. Minus into minus. Minus into minus.
Plus.
Omega square upon 2 into 2 4 minus k square upon 16 or 4 is equal to how much? 0. Got it? Means m omega square 1 4 we can take common out. One 4 going to the RHS. M omega square bracket square minus k square upon 4 is equal to how much? 0. Means m omega square bracket square is equal to how much? K upon 2 bracket square. K upon 2 bracket square. Okay. Means m omega square is equal to m omega square is equal to how much?
K by 2.
K
Plus
by,
or minus.
K by 2. K upon 2 yeah. Omega is equal to plus or minus under root K upon 2 yeah. K upon 2. This is the regular method for finding the frequency for oscillation. मेथड कोणताही लँग्वेज दिला असेल, वॉट एव्हर दे आर गिवन द लँग्वेज. फर्स्ट फाइंड आउट द मॅट्रिक्स ऑफ कायनेटिक एनर्जी. मॅट्रिक्स ऑफ कायनेटिक एनर्जी. सेकंड वन, राइट डाउन द मॅट्रिक्स ऑफ पोटेन्शियल एनर्जी. First matrix of kinetic energy, second matrix of potential energy. Next, write down the secular equation. Write down the secular equation. V minus omega square t is equal to 0. This is equal to 0. We're getting the omega value. We're getting omega value. Next. L is equal to 1 by 2m x dot square plus y dot square minus 1 half k x square plus y square plus 2 times xy plus 2 times xy. What is the kinetic energy matrix? T here y dot x dot
m by 2 0 m
y
by 2
dot x dot square coefficient m by 2, x dot y dot no coefficient 0, y dot x dot 0, y dot square coefficient m by 2. Potential energy V x y x into x square coefficient
k by 2
k by 2
by 2
xy
k by
xy
k by 2 सगळ्याचं k by 2 आहे k by 2 plus 2xy सर 2xy plus yx लिहावं लागेल सर 1xy 1 सर
always write down in the form of
plus y
symmetric.
by 2
Always write down in the symmetric form. This can be written as
y plus y
xy plus yx. Got it? Xy plus yx. 1 by 2 k into xy. Means this getting k by 2. This also getting k by 2. This also getting k by 2. Yes or no? K by 2, k by 2, k by 2. Write down secular equation. Yes. Secular equation. V minus omega square t is equal to 0. V minus omega square t is equal to 0. K by 2, k by 2, k by 2, k by 2 minus omega square m by 2, 0, 0, m by 2. Yes or no? Next. Is equal to how much? 0. Here is 1 by 2, here also 1 by 2. Here also 1 by 2, here also 1 by 2. We can take common out. Which part? From this equation, we can take common out. 1 by 2. Yes or no? We can take 1 by 2. Then this equation become k minus omega square m0 0 m. m0 0 m. Okay. K minus m omega square k minus m omega square is equal to how much? 0. Okay. A into a. K minus m omega square minus k into k square is equal to how much? 0. This is like that. A into a square minus k square is equal to k minus m omega square q a minus b bracket square a minus b bracket square sorry, a square minus b square k minus m omega square minus k equation 1. Second one, k minus m omega square plus k 0. Equation number 2. Plus k minus 2 get omega 0. And the second one, omega is equal to 2k upon m. Means omega 2 is equal to plus or minus 2k upon m. Got it?
Yes, sir.
How to solve this one? A minus b bracket square. This is like that, a square minus b square. A minus b, a plus b.
सर रूट क्या आएगा?
Root. This k plus this k, 2k. A root plus or minus root 2k upon m. Yes, any doubt?
No, sir.
Sound कुणाचं तर रिफ्लेक्ट होता. Yes, any doubt in this case?
No, sir.
Here also we can use a minus b bracket square method. A minus b bracket square method. No, sorry, a plus b, a minus b. A square minus b square, a plus b. M omega bracket square minus k by 2 bracket square is equal to 0. And this is equal to how much? M omega square minus k by 2 is equal to 0. M omega square plus k by 2 is equal to how much? 0. We get two values.
इक्वेशन पहिल्या प्रॉब्लेमला पण 2 करायचं का?
स्प्लिट करून येते का व्यवस्थित आन्सर? Next problem. L is equal to 1 by 2. L is equal to 1 by 1 by 2 m2 x2 dot square. हाँ बोलो.
तर ते आधीच्या प्रॉब्लेमला पण तसंच करायचं का? मग 2 फ्रिक्वेन्सी त्याला पण मिळतील ना?
बघा ना मिळतायत का? m2 mass m1 m2. What is the kinetic energy for first particle?
ओके सर.
Kinetic energy for first particle x1 dot. What is the kinetic energy for second particle? x2 dot. Yes or no? This one is a velocity. And what is the displacement? Displacement. Mass m1, velocity x1. Mass m2. What is the actual displacement here? Displacement x2 minus x1. Yes or no? x2 minus x1. Then Lagrange minus 1 by 2. 1 by 2 k. What is the displacement? x2 minus x1 bracket square. Means Lagrangian L can be written as 1 by 2 m1 x1 dot square plus 1 by 2 m2 x2 dot square plus 1 by 2k, 1 by 2k, yes, x1 square plus x2 square minus x1 x2 minus x2 x1. Yes, any problem? Kinetic energy T. Here also 1 by 2, here also 1 by 2. Then we can don't write down 1 by 2. Why? Because we can write down the secular equation. 1 by 2 we need to take common out. Yes or no? म्हणजे या केस मधून 1 by 2 काय होईल? कॉमन निघेल आणि तो 0 कडे जाईल. Got it? x1 dot x2 dot x1 dot x2 dot. Here also x1 dot x2 dot x1 dot x1 dot x1 dot square coefficient x1 dot square coefficient simply m or m by 2 m. आता आपण हाफ घेणार नाही, हाफ दोन्ही मधून कॉमन घेऊ, 0 कडे जाऊ. नेक्स्ट x1 dot x2 dot 0 x2 dot x1 dot 0 x2 dot x2 dot m. Potential energy V x1 x2 x1 x2 x1 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 square coefficient x square x1 square coefficient k x1 x2 coefficient x1 x2 coefficient minus k x2 x1 coefficient 1 into k minus 1 into k minus k x2 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 square coefficient. Here sign is minus, huh? Minus 1 by 2 kx. Okay. What is the kinetic energy matrix? Kinetic energy matrix M 0 0 M. What is the potential energy matrix? Potential energy matrix K minus K plus K. This is kinetic energy part. This one is a potential energy part. Next, write down secular equation. Secular equation V minus omega square T is equal to how much? 0. V minus omega square T is equal to how बोला?
Kinetic energy matrix. Kinetic energy matrix मध्ये M1 M2 येईल ना?
M1 M2, yes. M1 M2 because here masses are same one. So masses different. Potential energy K minus K K. Okay. Omega square. What is the kinetic energy? M1 0 0 M2 is equal to 0. Kyle?
M by 2. Sir?
M by
2 M2 by 2.
नाही हा 1 by 2 कॉमन घेणार ना आपण. इथे 1 by 2 येईल. 1 by 2 into this. मी ते सांगितलं तुम्हाला दोन्ही केस मधून 1 by 2 तुम्हाला कॉमन घेता येईल. दोन्ही केस मधून कॉमन घेता येईल तो कुठे 0 होईल? This into this. Yes or no? AB is equal to 0 implies that A is equal to 0, B is equal to 0. 1 by 2 is not equal to 0 means implies second part is equal to 0. Got it? This is possible only if here also 1 by 2, here also 1 by 2. लक्षात आहे दोन्हीकडे 1 by 2 असेल तर 1 by 2 तुम्ही नाही दिला तरी चालेल. लक्षात येत आहे नसेल तर मात्र तुम्हाला इथे 1 by 2 आहे आणि इथे 1 by 2 absent आहे तर डोंट टेक दिस 1 by 2 कॉमन आउट. ऑलवेज मेमोराइज. Yes, K minus M omega square minus K minus K minus M omega square is equal to how much? 0. K minus M omega square, sorry, M1 M2 M1 omega square into K minus M2 omega square minus K square is equal to how much? 0. Is equal to how much? 0. Means K minus M1 omega square into K minus M2 omega square minus K square is equal to how much? 0. A into A. This become A square. These two quantity are same or different?
Different.
Then we cannot take square of this part.
Different.
Okay, means we cannot take there. Here is a
Yes,
square. Then K into K. K square. Okay, K into
Square.
M2 omega square. Next, minus M1 k omega square. Next, minus into minus, minus into minus, plus m1 m2, m1 m2, omega square, omega to the power 4, minus k square is equal to how much? 0. Minus k square is equal to 0. Which part get cancelled? Plus k square minus k square get cancelled. Yes or no? This k into k, k square. This k square is plus, this k square is minus. Plus minus get cancelled. Then omega raised to 4. Omega raised to 4. M1 M2. M1 M2 minus k m2 omega square minus m1 k omega square is equal to how much? 0. Is equal to 0. From whole equation we can take common out.
Omega square common out.
Omega square common out. Okay. Then omega square into here m1 m2 omega square minus k m1 minus k m2 bracket complete 0. Bracket complete 0. Then omega square m1 m2 omega square minus k m1 minus k m2 is equal to how much? Is equal to 0. AB is equal to 0 implies that A is equal to 0, B is equal to 0. Means omega square is equal to 0. First one. And second one, m1 m2 omega square minus k m1 minus m2k is equal to 0. And this is equal to how much? m1 m2 omega square is equal to k m1 plus m2 yes or no? Then omega square is equal to yes k m1 plus m2 upon m1 m2 means what is the value of k? Sorry, what is the value of omega? Omega is equal to plus or minus under root k m1 m2 upon m1 m2. Dimensionally this one is correct. We know that dimensionally k upon. Dimensionally these two quantities are same or different?
Correct, sir.
Yes. Here denominator m to the power 2. Here m to the power 1. One power get cancelled. One frequency 0. Another frequency plus or minus under root k m1 plus m2 upon m1 plus m2. This part is known as m1 plus m2 upon m1 plus m2. m1 plus m2 is known as 1 upon reduced mass. Yes or no? Because it is a two particle. A diatomic molecule is converted into monatomic molecule or a single. 2D problem is converted into two body problem is converted into single body problem using a reduced mass concept. Yes or no? Means this is equal to omega is equal to plus or minus k upon em. Okay, here is a two masses. First mass, this one is a second mass. Okay, now here support is rigid movable. Here support is rigid movable. Support rigid movable. Here support is absent. Yes or no? Here is a no support. Here is a no reference. No reference. Then no reference. Then one frequency is. One frequency always. One frequency always. How much? Always 0. लक्षात घ्या. Always 0. म्हणून omega 1 is equal to 0. But omega 2 is not equal to 0. Got it? Why? Because here is one particle considered as a rest. This one is a reference. With respect to this, This particle is movable. Both are movable. We cannot say this system is in motion. Yes or no? Because there is no reference. Here support is rigid. We can take support is here. Then omega 1 is not equal to 0. Omega 2 also not equal to 0. Got it? Suppose system is like that. Omega 1 0 non-zero. Omega 2 0 non-zero. Omega 1 non-zero. Omega 2 non-zero. Okay? System is like that. Omega 1 0 non-zero. Omega 1 0 non-zero. Omega 1 0. Omega 2 non-zero. Omega 3 non-zero. Got it? Means here we need to consider one point as a reference, one particle as a reference. Remaining all are is in motion. Yes, any doubt in this case?
सर मागचा पेज घ्या ना.
Yes, या केस मध्ये काय अडचण?
नाही सर नाही.
Here these two particles are equal and equal.
Unequal.
Unequal. Suppose these two particles are same.
तर मास सेम असला.
M1 is equal to M2. Then omega is equal to how much? M plus M.
2m1 upon 2m. 2m.
We getting same answer, different answer. Omega 1 is equal to 0, omega 2 is equal to 2.
सर काय हे परत सांगा ना सर.
M1 is equal to M. These two masses will be same. These two masses same. Omega 1 0, omega 2 under root 2k upon M.
सर इथं मायनस साइनला कन्सिडर. हॅलो सर.
हाँ माइनस नहीं तर डायरेक्ट प्लसच घ्यायचं.
पोटेन्शियलच्या वेळेस पोटेन्शियलचे कोएफिशिएंट घ्यायचे असतात.
नाही फ्रिक्वेन्सी घेताना डायरेक्ट प्लसच मध्ये घ्यायची. डोंट टेक मायनस हियर. घेताना प्लस मायनस येईल पण आपल्याला घेताना मात्र प्लसच घ्यायची. यामध्ये प्लस आणि मायनस मीन्स साऊंड ऑफ करा.
नाही सर पोटेन्शियलचा जो आपण डिटर्मिनंट काढतोय ना.
बर
तर तिथे जे कोएफिशिएंट असतात त्याच्यामध्ये ती मायनस साइन कन्सिडर नाही करायची का सर?
which sign?
दोन मिनिटं सर.
हे मायनस घेतलं ना आपण. दिस इज मायनस, दिस ऑल्सो मायनस.
सर प्रिव्हियस एक्झाम्पल मध्ये बघा तर सर.
हा बोला.
सर याच्या अगोदरचं एक्झाम्पल बघा तर 2 मिनिटं.
हा
सर इथे बघा सर.
ठीक आहे. प्लस एक्स वाय मायनस प्लस एक्स वाय चे दोन्ही पण प्लस प्लस म्हणून प्लस घेतलं इथे.
नाही सर ती जी मायनस साइन आहे ना ब्रॅकेटच्या बाहेर
हो.
-1/2
लॅग्रेंज इज इक्वल टू हाऊ मच?
T minus 3 करेक्ट सर. येस सर येस सर.
म्हणजे पोटेन्शियल आपल्याला प्लस साइन येईल. इथे जर प्लस असतं तर मग मायनस घ्यावं लागलं असतं ऑल कंपोनंट साठी. कायनेटिक एनर्जी. आवाज का येतो रिपीट?
आवाज रिपीट होतोय सर.
का बरं?
नाही सर आमच्यासाठी नाही होते रिपीट.
नाही आता होत होता. आता नाही होते. मगाशी झालं.
M. All masses are equal. All masses are equal. This particle moving in the direction velocity x1 dot. This particle moving in the direction velocity x2 dot. This particle moving in the direction velocity x3 dot. Yes, displacement Displacement. Here is x2. Here x1. Here is x3. First displacement. First displacement.
x2 minus x1.
x2 minus x1. Second displacement.
x2 minus x3 minus x2.
x3 minus x2. x3 minus x2. Okay. All particles having the same mass. Then Lagrangian L is equal to how much? 1 by 2. Velocity of first particle x1 dot square. Second particle x2 dot square. Third particle x3 dot square. Minus 1 by 2k. Yes, 1 by 2k. First displacement x2 minus x1 bracket square plus x3 minus x2 bracket square. Kinetic energy. Here also 1 by 2, here also 1 by 2. No need to write down 1 by 2 in matrix. 3 by 3 matrix. M 0 0 0 M 0 0 0 M. This is the kinetic energy matrix. Got it? Next, potential. K x1 square plus x2 square minus x1 x2. आवाज ऑफ करा. x3 square x2 x3 minus potential energy matrix x1 x2 x3 x1 x2 x3 x1 square coefficient x1 square coefficient k x1 x2 coefficient x1 x2 coefficient x1 x2 coefficient minus k x1 x3 coefficient x1 x3 coefficient x1 x3 coefficient
0 minus k sir. x1 x0 0.
No any x1 x3 component is there. Next
x1 x3 0 sorry.
x2 x1
x2 x1 minus k
x2 square coefficient
x2 square k
x2 square coefficient
k
x2 square coefficient
2k.
k 2k sir 2k.
this one is x square, this also
K
x
sir.
square 2k x2 x3
Okay. Minus k.
x2 x3 minus k x1 square x3 x1
x3 x1 0
x3 x2
x3 minus 2k k sorry minus k sorry 3 2 minus 2k
x3 x2
Minus k.
minus k
Minus k.
minus k
x3 plus x2 minus k.
x3 square
Plus k.
potential energy
k
k minus k 0 minus k 2k minus k 0 minus k k. Yes or no? Here is a matrix 3 by 3 matrix. Then secular equation v minus omega square k is equal to, okay, 1 by 2 already we can take common out, going to 0 side becomes 0. Yes, v k minus k
Minus k.
0
0.
minus k 2k minus k 0 minus k plus k. minus omega square t m 0 0 0 m 0 0 0 m. Subtraction लक्षात येते. This minus this, this minus this, this minus this. Okay, similar. This minus this minus this, and so on. Yes, first one. K minus
minus m omega square
next minus k next 0
minus k 0
next
minus k
2k
minus 2k minus m omega square
minus k
minus k
0
0 0 नहीं minus 0 minus k 0 नहीं sir minus k minus m omega square k minus m omega square.
yes multiplication व्यवस्थित करा. k m omega square k minus m omega square into 2k minus m omega square into k minus m omega square minus k square. First part over second part plus k minus k
plus k in bracket minus k into k minus m omega square.
k minus m omega square into 0 is equal to how much? 0. Okay, next. K minus k
K minus m omega square common.
K minus
omega square common.
चालेल कॉमन घेतलं तर k minus m omega square. Okay. Inside the bracket 2k minus m omega square k minus m omega square minus k square.
Minus k square.
Okay, from this equation we can
Minus k
take
square.
k minus m omega square means here we are getting minus k square is equal to 0. Okay.
Minus
From this equation we are getting one frequency. Yes. 2k minus m omega bracket square k minus m omega square minus k square, and from this equation k minus into minus plus k into k minus m omega square. Okay, here sign is a minus, here sign plus, plus into minus minus k square. From this equation we are getting one frequency k minus m omega square is equal to ab is equal to 0 implies that a is equal to 0, b is equal to 0, then m omega square is equal to k, means omega is equal to how much? Under root k upon m. This is the frequency number 1 or frequency number 2, any one of these. Next, focus on this part.
Sir,
Focus.
first time omega is equal to under root plus or minus k by a.
2k square minus 2k m omega square minus m omega square k
m omega square k
minus into minus plus m square.
plus m square omega raised to 4.
Okay, and this minus k square
minus 2k square.
minus 2k square is equal to how much? 0. Which part get cancelled? Plus 2k square minus 2k square get cancelled. M square omega raised to 4. Again, we can take one omega square is common out. From this equation, we can take
m omega square.
m omega square common out. M omega square common out. What is the inside? M omega square
Minus 2k minus k.
minus 2k
3 na sir. Minus 3.
minus 3k. M omega square we can take common out. Again, AB is equal to 0 implies that A is equal to 0. M omega square is equal to 0. And second one, M omega square minus 3k is equal to 0. Means here omega is equal to 0. Here omega is equal to how much? Under root 3k upon 3k upon m means omega 1 0, omega 2 under root k upon m, omega 3 under root 3k upon m, under root 3k upon. This is the three frequency of three atoms. How many atoms here? Atoms 3. Means we getting how many frequencies? 3 frequency. Here we getting 3 frequency. Here support is not rigid. Okay, support is not rigid or support is not fixed. Means out of 3 particles, 1 particle considered as a 1 frequency is equal to how much? 0. 1 frequency 0. Hence we getting omega 1 is equal to 0. Always memorize. 1 frequency in this case how much? 0. Omega 1 0. Omega 2 under root k by 2 under root k upon m. Yes. Any doubt?
सर सेकंड क्वाड्रेटिक इक्वेशन कसं सोडवं थोडं सांगा ना.
Second one, this.
म्हणून घेतलेलं एकदा सांगा k minus m omega square.
Here m omega square is common out.
त्याच्यावरची स्टेप सर.
यामध्ये हे काय त्या दिस हे
त्यामध्ये कशी कशी
ही स्टेप का?
हा ती दोन्ही याच्यातनं कॉमन आहे. फर्स्ट टर्म कॉमन येते कारण 2 वेळा येते.
हे बघा. First a this into this minus k into k square. Okay, minus k square. लक्षात आलं? k minus m omega square into 2k minus m omega square into k minus m omega square. Okay, minus into minus plus k square. Okay, म्हणजे first part is over. Second one, minus into minus plus minus k into k minus m omega square. Okay.
हा ती कळालं.
Okay, this is equal to how much 0. आता यामध्ये हा पार्ट जो आहे हा कॉमन आहे. We can take common out. Okay, हा कॉमन घेतला आपण. हा कॉमन घेतल्यानंतर हा k this k into this k become minus k square. Okay, and this part is shifted here. This part is shifted here. What is the remaining part? Remaining part is this one. Then just multiply this one 2k into m omega square. Okay. Next, omega into 2 omega into m omega square into k, m omega square into this one. Yes or no? Because here is a multiply of these two components. That's it. We're getting 2k square. This one. But here 2k into k, 2k square plus here minus k square minus k square. This become minus 2k square. Minus 2k square plus 2k square get cancelled. Next, from this case, here m is a common. M. Take common out. किंवा इथं असंही करता येईल. Minus 2k m omega square minus m omega square k is nothing but 3 minus 3k m omega square plus m square omega raised to 4. Yes or no? Omega raised to 4 is equal to how much? 0. आता यातून काय कॉमन घेता येईल आपल्याला? m omega square. Then what is the remaining? M omega square minus 3k is equal to 0. AB is equal to 0 means A is equal to 0, B is equal to 0. Means omega is equal to 0 from first one. And the second one, M omega square minus 3k is equal to 0. Means omega square is equal to 3k upon m. Means omega is equal to how much? Under root 3k upon m. Go. Next. One by 2 m. One by 2 m L square. Yes. 2 theta 1 dot square plus theta 2 dot square plus 2 times theta 1 dot theta 2 dot theta 1 2 dot theta 2 dot plus mgl cos theta 1 mgl cos theta 2. This is the 2 times, okay, 2 times mgl cos theta 1 plus mgl cos theta 2. This is the Lagrangian for double pendulum. This is the Lagrangian for double pendulum. 1 by 2 ml square 2 theta 1 dot square plus theta 2 dot square plus 2 times theta 1 dot theta 2 dot bracket complete plus 2 mgl cos theta 1 plus mgl cos theta 2. Cos theta 2. Okay. Here potential energy sign positive negative. Here potential energy sign positive negative. इधर प्लस है मतलब पोटेंशियल एनर्जी साइन नेगेटिव पॉजिटिव माइनस mgl cos theta 1 2 times plus mgl cos theta 1. Okay, here we can use the small oscillation. Small oscillation sin theta is equal to small oscillation sin theta is equal to theta and cos theta approximation
1 minus theta square by 2. This no sir?
yes 2 mgl 1 minus here is the theta 1 means theta 1 square by 2 plus mgl 1 minus theta 2 square by 2. Kinetic energy
Theta 1 dot square 2 dot square 2 dot 8.
theta 1 dot
theta 2 dot
Square.
theta 2 dot here also theta 1 dot theta 2 dot theta 1 dot square coefficient
2 ml square.
2 ml square
2 ml square.
theta 1 dot theta 2 dot theta 1 dot theta 2 dot
ml square.
ml square. Okay,
Square.
this also square.
Again ml square. No?
Again ml square. Potential energy minus into minus plus. Okay, and this is equal to 2 mgl minus plus
Half बाहेर घेतलं का तुम्ही?
yes
Sir, half kinetic energy चा half.
बाहेर घेतलं ना आपण ते minus plus 2 mgl theta 1 square upon 2 plus mgl theta 1 square upon 2 mgl theta 1 square upon 2 plus a plus b means A and B are constant. Don't take here. Okay, constant जर सेपरेट पार्ट असेल तर तो मॅट्रिक्स मध्ये नाही घ्यायचा. लक्षात येतं 2mgl आलं ना हे 2mgl आणि this become plus mgl or minus mgl. Neglect this one. Only focus on this part. Yes. Here also 1 by 2. Here also 1 by 2. This also 1 by 2. Or we can take here is 1 by 2. Here is 1 by 2. Here theta 1 dot, sorry, theta 1, theta 2, theta 1, theta 2. Theta 1 square coefficient. Theta 1 square coefficient.
2mgl.
2 mgl.
GL.
2 mgl. Theta 1, theta 2.
0.
0. Theta 2, theta 1.
0.
0. Theta 2, theta 2 dot. Theta 2, theta 2.
Minus mgl.
Minus
Minus mgl.
plus. This minus plus. This minus plus. Okay. Means T is equal to how much? T is equal to S 2 ml square. 2 ml square. ml square. ml square. ml square. Next 2 mgl potential energy. 2 mgl 0 0 mgl. Next step. Next step, write down. Circular
matrix.
V minus omega square T is equal to how much? 0. What is the potential energy? Potential energy 2 mgl. Kinetic energy? Yes.
2m square L square.
2 minus
2m omega square L square.
omega square L square. Second component. Second component.
ml minus ml square omega square.
Minus ml square
Minus ml square omega. ml square omega square.
omega square. Minus ml square omega square.
Omega.
mgl minus
ml square omega square.
ml square omega square is equal to.
Equal to 0.
Got it? From whole equation we can take common out.
mgl
mgl. We can take mgl is common out, then this become 2 minus 2 L upon G omega square. This one no, L upon G omega square minus ml means L omega square upon G minus L omega square upon G. 1 minus
सर कॉमन ना कर दे डायरेक्टली केलं तर नाही चालत का
कॉमन काय घेते म्हणे
कॉमन ना करता डायरेक्टली आपण
कॉमन न करताही सॉल्व करता येईल थोडंसं डिफिकल्ट होईल किंवा तुम्हाला
नाही ना त्याच्यानं कॉमन काढता येईल लवकर
या केस मधून काय घेता येईल आपल्याला ml घेतलं तर चालेल सपोज ml घेऊ थोडंसं डिफिकल्ट वाटतं तर ml घेऊ ओनली we can take ml is common out only, that's it. ml is common out, then this become 2g minus 2 omega square L. Next ml minus L omega square minus L omega square G minus ml L omega square is equal to 0. त्यापेक्षा हे सोपं वाटतंय. ओके गॉट इट.
सर ते कॉमन
चालेल ना, नो प्रॉब्लेम.
मग ते जातं ना, हे कॉमन काढून परत करण्यापेक्षा त्याच्यात इक्वेशन मिळून जातं, पटकन निघतात.
नाही पटकन निघायला नाही काय अडचण, फक्त ते थोडं लेंथी वाटेल तुम्हाला. असे ज्यावेळेस तुम्ही जवळ एखाद्या 2 टर्म्स आपल्याला कॉमन घ्यायचे किंवा अटॅच करायचे, त्यावेळेस थोडंसं कॉम्प्लिकेशन वाढू शकतं. आता इथं पॉवर एवढ्या हे पाहताना आणि हे पाहताना विच वन इज द सिम्पलेस्ट वन. आता एमएल तर 0, एमएल इज नॉट इक्वल टू 0 मीन सेकंड पार्ट इज इक्वल टू 0. हे मल्टिप्लिकेशन करताना थोडंसं लेंथी होईल, एवढाच प्रॉब्लेम आहे त्या केसमध्ये. तुम्हाला जर हे सोपं वाटत असेल तर हे डायरेक्टली तुम्ही काही कॉमन न करता डायरेक्ट सुद्धा सॉल्व्ह करू शकता, काही अडचण नाहीये. फक्त हे थोडंसं मल्टिप्लिकेशन लेंथी होईल, दॅट्स इट. नेक्स्ट, this into this 2g minus 2 omega square L into g minus L omega square minus minus plus L square omega to the power 4 0. Omega to the power 4 is equal to 0. How to solve this one? One method, we can just multiply everything. ते 2 multiply करा आणि solve करा first. किंवा second one adjustment करा. Here we can take 2 is common out. Okay, 2 take common out. G minus omega square into G minus L omega square plus L omega square bracket square is equal to 0. Yes, any problem? Next, again we can adjust something. Adjust means write down here root 2 G minus L omega square bracket square plus L omega square bracket square is equal to 0. चालेल का? रूट टू स्क्वेअर 2 G minus L omega square bracket square
A plus B A minus B.
G minus L omega bracket square
काय म्हणतो?
G minus L omega square bracket square is equal to G minus L omega square into GL minus L omega square.
Plus 2. Yes.
ओके, लक्षात येतं. आपण अशा फॉर्मॅट मध्ये काय ऍडजस्टमेंट करतोय? येस, हा कोणता फॉर्मॅट आलाय? ए स्क्वेअर मायनस बी स्क्वेअर फॉर्म. आता परत तुम्ही एवढं मल्टिप्लिकेशन करायचं म्हणलं टाइम्स वाढेल, परत एखादी पुढे टर्म झाली की परत कॉम्प्लिकेशन्स वाढतील. येस ऑर नो? फॉर दिस point of view we can adjust this into this is square. Okay, but here is a 2. Write down a square minus b square means here 2 can be adjusted as a root 2. A square minus b square. L omega square is equal to 0. First one. And second one, root 2 G minus L omega square plus L omega square is equal to 0. Root 2G minus root 2L omega square minus L omega square is equal to how much? 0. Root 2G, here omega square we can take common out, minus omega square. L also we can take common out. L common out. Here is a root 2 plus 1. Root 2 plus 1. Okay, is equal to how much? 0. Then omega square is equal to how much? Omega square is equal to, yes, or root 2 g upon root 2 plus 1, root 2 plus 1. Here L is multiplied going to this side, this become plus. Means first frequency omega 1 is equal to under root 2g upon root 2 plus 1 into L root L upon G. Root L upon G. Okay, and what is the second frequency? Omega 2 is equal to getting, yes, root 2 upon root 2 minus 1 under root L upon G. Under root L upon G.
सर या अगोदरचा प्लीज पेज दाखवा ना तो.
लक्षात घ्या किंवा तुम्हाला असं ऍडजस्ट करता येईल. टी म्हणजे या केस मध्ये कसं घेता येईल, θ1L θ2L. ओके, मग L जर घेतला तर त्या केस मध्ये किती येणार मग 2m m. लक्षात येत आहे. पण इथंही मात्र हे कसं ऍडजस्ट करावं लागेल मग, θ1L θ2L θ1L. या केस मध्ये काय करावं लागेल आपल्याला, एक हे येताना कसं येईल मग 2mg upon L, 2mg upon L, because L into L square coefficient is 2mg upon L. Got it? म्हणजे इथं एक L काय करावं लागेल तुम्हाला, डिवाइड करावं लागेल. डिवाइड कशासाठी करावं लागेल, L into L स्क्वेअर, म्हणजे एक L आपल्याला कॅन्सल होईल, वी बी गेटिंग 2mg. लक्षात आलंय. जर तुम्हाला अशा फॉर्म मध्ये घ्यायचंय तर इथं एक L ऍडजस्ट करायचं. कशासाठी, L into L स्क्वेअर कोएफिशियंट 2mg upon L. इथं Lच आहे ना, येस सर नव्हतं, आपल्याला काय लागेल मग L स्क्वेअर θ1 स्क्वेअर. हेन्स वी कॅन राईट डाऊन मल्टिप्लाय बाय L डिवाइड बाय L. होते का डायजेस्ट की नाही. Yes, any doubt?
No sir.
L is equal to 1 by 2 m q1 dot square plus 2m q2 dot square minus k 5 by 4 q1 square plus 2q2 square minus 2 times q1 q2 minus 2 times q1 q2. जसं लॅग्रेंजियन टू हॅमिल्टोनियन और हॅमिल्टोनियन टू लॅग्रेंजियन घेताना आपल्याला कोणता कंपोनेंट मस्ट आहे, which part is important, which value is important, 1 by 2 is important. Yes or no?
Yes sir.
Similarly here also Lagrangian means kinetic energy 1 by 2 must be important. Yes or no? इथं 1 by 2 absent आहे, याचा अर्थ काय, here 1 by 2 is absent means
तू हे घेवा लागेल सर 1 by 2.
1 by 2 absent आहे, याचा अर्थ काय, इथं एक 1/2 होता, पण इथं 2 च्या ऐवजी किती असेल? 4 असेल. येस or no?
Q2 dot square
Minus k.
minus 1/2, sir.
We can take 2 is common out. Then this become 5/2
5/2
Q1.
or Q2 dot square Q2 square.
Okay, means this is equal to how much? 4
Q2 square minus 4 Q1 Q2.
Why we can take 2 is common, 1/2 is common out? आपण 1/2 का कॉमन घेतोय? फॉर सिम्प्लिफिकेशन, दॅट्स इट. तुम्हाला जर नसेल करायचं तर या केसमध्ये तुम्हाला 1/2 कॉमन घेता येणार नाही. वी कॅन नॉट टेक हिअर 1/2 कॉमन आउट फ्रॉम कायनेटिक एनर्जी अँड पोटेन्शियल एनर्जी. राईट डाउन ऍज इट इज, वॉट एव्हर द पार्ट. गॉट इट? But now we can adjust here 1/2, then we can take 1/2 is common out. Kinetic energy T. Kinetic energy T. Q1 dot.
Like Q1 dot Q2 dot Q1 Q2. Q1 dot into Q1 dot only answer. M.
Q1 Q2.
Q1 0 4M.
Only possible we can adjust the 1/2. Otherwise we cannot take common out 1/2. Kinetic energy. Potential. Q1 Q2. Q1 Q2. Q1 square coefficient.
I/2 K.
Q1 Q2.
Minus 2K.
Good. Minus 2k.
2K.
Q2 Q1.
Minus 2K.
Q2 square.
4K.
4k. Next. हे लक्षात आलं का 1/2 काय ऍडजस्ट केलं आपण? We can take 1/2 is common out. Okay? Second equation. V minus omega square t is equal to 0. V 5k upon 2 minus 2k 4k minus omega square m 0 0 4m. How much? This is equal to 0. Yes. 5k by 2 minus m omega square.
M omega square.
Next. Minus
2K.
2k minus 2k. Next. 4k minus
4 omega square. 4 omega square.
4 m
M omega square.
4 m omega square is equal to 0. 5k by 2 minus m omega square into 4k minus 4k minus 4m omega square minus 2k
Minus 4K. Square equal to 0.
From this equation we can take common out. From whole equation we can take common out.
Common out.
4 we can take common out.
Yes, sir. 4.
Here is 4, here is 4, here also 4. Going to this side. Next. 5k by 2 minus m omega square into k minus m omega square minus k square is equal to how much? Is equal to 0. Next. Suppose whole equation we can multiply it by 2. Whole equation multiplied by 2. Then this become 10k minus 2m omega square.
Sir, 2 get cancelled, but
Sir, 5K is it, no?
Okay, 5k.
Sir.
5k minus 2m omega square into 2k हे सर एकाच ब्रॅकेटला काय होईल मल्टिप्लाइड होईल ते 5 5 5 5
5k square 5km omega square minus 2m omega square k plus 2m square omega to the power 4.
ek square
Minus 7km omega square plus 3k
k
square.
omega k square
3k square equal to 0.
yes sir
quadratic equation in omega.
quadratic here power is 4
To get outside.
Omega square, so.
then we consider omega prime is equal to m omega. Omega prime is equal to m omega. Then this become m to m
M omega square.
prime square.
Sir.
Okay.
Sir, m पण देतो. To omega prime square.
Minus 7k
Plus 7
omega
minus 7
prime.
to
Omega prime plus 3k square.
plus 3k square equal to 3.
Minus plus 3k square is equal to 0. A 2
Equal to
B
b equal to minus 7k
Minus 7k
3.
3k square.
Minus b plus minus under root b square minus 4ac divided by 2e. Minus 7k plus minus 49k square minus 24k square 24k square divided by 4.
Forty-nine minus this one.
5k 4 3 12k by 4 and 2k by 4 2k by 4
2k by
3k k by 2 3k k by 2 3k k by 2.
We know that omega prime is nothing but omega prime is nothing but
Omega prime m omega square.
m omega square is equal to how much? 3k upon 2 means omega 1 prime omega 1 square is equal to 3k upon 2m means omega 1 is equal to how much? Under root 3k upon 2m 3k upon 2m. Next omega prime 2 prime square means omega 2 square m is equal to k upon m means omega 2 square is equal to k upon 2m k upon 2m means omega 2 is equal to which under root k upon 2m. Yes. Yes, any doubt? Yes.
सर फक्त 3 येईल ना सर तो
3 by m.
तुम्हाला जे 3.5 मार्क आहेत, दिस इज 3.5 मार्क्स नेट प्रॉब्लेम ओनली फॉर ऍडजस्टिंग 1/2. दॅट्स इट. फक्त 1/2 ऍडजस्ट करायला तुम्हाला 3.5 मार्क आहेत. एव्हरीथिंग वी कॅन डू दिस. तुम्हाला बाकी सगळं जमेल, फक्त फर्स्ट 1/2 ऍडजस्टिंग साठी तुम्हाला 3.5 मार्क्स आहेत, लक्षात घ्या. Yes. Potential energy. Potential energy. Potential energy minus plus.
Minus mgl cos theta.
Minus mgl cos theta is equal to how much? Minus mgl cos theta.
1 minus theta
theta square by 2. we know that here L theta dot is equal to how much? X dot. Yes or no? Theta is equal to x upon L. L theta dot is equal to this one. Then theta dot is equal to x dot upon L.
X dot.
X dot upon L. Okay. Yes, what is the potential energy? V is equal to minus become minus mgl plus mgl. Yes. mgl theta square.
X dot square upon L square.
L theta is equal to x. L theta is equal to x. L theta is equal to x. Then theta is equal to
X upon L.
x square upon L square.
L square.
Okay, mean this is equal to how much? mg. When L get cancel. X square upon
X square upon to L square. L square plus L only L.
kinetic energy T. Kinetic energy T.
T X dot
X dot. Second one.
and theta dot.
Huh? Theta dot L theta dot.
Theta dots.
L theta dot. Okay. X dot square coefficient. Capital M.
M.
Second X dot square coefficient.
X.
First capital X dot square coefficient. Capital M. Second X dot square coefficient. Small m.
M.
Capital M plus small m. Okay.
Capital M plus small. Yes, sir. Second, sir. Second. M. Okay, sir. L theta dot X dot. X dot.
L theta dot X dot.
2 M's. 2
L theta dot X dot.
2 M.
Always write down in the form of symmetric.
Symmetric there.
Symmetric, this can be written as 1 plus 1. 1 plus 1 means what is the coefficient here? Coefficient is m. L theta dot X dot coefficient. L X dot theta dot coefficient m. Next, L theta dot X dot m.
Then L square theta dot square.
Next, L square theta dot square. L square theta dot square. Small m. Okay.
Yes, sir.
Potential energy V. X
L theta
this is a theta part, huh? Okay. This is a theta parts.
theta
Theta part is ठेवा हे difficult होईल मग. This is equal to किती मग mgl theta square by 2. mgl theta square by 2. Okay. mgl theta square by 2. Here x, here l theta, here also l theta. मग काय करावं लागेल आपल्याला इथं l स्क्वेअर घ्यावं लागेल, डिनॉमिनेटरला l ऍडजस्ट करावं लागेल. x स्क्वेअर कोएफिशिएंट x स्क्वेअर कोएफिशिएंट
No, x square 0.
0. x l theta dot sorry x l theta,
XL theta be
only one component is there. Okay.
sir.
0.
X
L theta x
0
0. Next
0
L square theta square
mg
L square theta square mg
mg.
upon 2l.
अच्छा.
हे लक्षात आले का? Minus mgl cos theta. Cos theta can be written as 1 minus theta square by 2. And this is equal to how much? Minus mgl. Minus plus mgl theta square upon 2. Constant part we can neglect this one. Always memorize. This part neglected. Which part? First part neglected. Means this is equal to how much? mgl theta square upon 2. Okay. How to adjust this one? This can be written as mgl square theta square upon 2l. Why we can take l square in numerator? Because here we can take coefficient of this one. Next circular equation. V minus omega square t is equal to 0. What is the value of v? V 0 0 0 mg upon 2l minus omega square capital M plus small m is equal to 0. Got it? Any doubt up to here? Up to here, any problem?
No sir.
Cross multiplication minus omega square capital M plus small m into mg upon L minus m omega square minus m omega square, minus into minus plus, sorry, minus into minus m square omega to the power 4 is equal to 0.
mg by 2l है ना?
mg by 2l, yes. From this equation we can take common out. From this equation we can take common out. Omega square minus capital M small m into mg upon 2l minus m omega square minus m square omega square is equal to how much? 0. Next, omega square is equal to 0. Omega square is equal to 0. Next,
0
m plus small m mg upon 2l minus m omega square
minus plus m square omega square.
Which part get cancelled? From both sides, which part get cancelled?
Which part is cancelled? M square omega square.
M square omega square.
M square omega square cancel.
Omega square.
M square omega square.
M plus 1, okay, minus into minus plus M plus small m, this minus M omega square किंवा आपल्याला स्प्लिट करता येईल. ओके, capital M plus small m, mg upon 2l, okay. This m multiplied with this side, this m small m omega square plus small m square omega square is equal to small m square omega square. Which part get cancelled? Small get cancelled. Okay. Next. Minus capital M small m mg upon 2l plus capital M small m omega square is equal to 0. From this equation we can take common out. Minus capital M small m g upon 2l small m we can take common out plus m omega square is equal to 0.
Where is to 4 येईल सर?
4 कसं येईल? 4 कसं येईल?
ओमेगा स्क्वेअर. हा नाही सॉरी कॉमन ओके सर बरोबर.
M tends to infinity. M tends to infinity.
Second term is 0. Second term
Tends to infinity.
Okay.
Capital M minus. Omega 2 tends to infinity.
Omega is equal to under root g by 2l.
Kinetic energy matrix T. Here also 1 by 2, here also 1 by 2. No need to write down 1 by 2. X dot, Y dot, X dot, Y dot, X dot, X dot, X dot square coefficient. X dot square coefficient.
1.
Absent means, what is the meaning of that? Absent means here is a unit mass. Okay. Nothing means unit mass particle. Okay. Unit mass particle. Okay. Mass is 0. Kinetic energy.
0.
Mass 0, kinetic energy 0. म्हणून ते 0 नाही लक्षात घेता येणार. लक्षात येत आहे?
0.
Unit mass 1. X dot, Y dot. X dot, Y dot.
X dot Y dot
0.
Y dot, X dot.
0.
Y dot, Y dot.
0. 1.
1.
Kinetic energy 1 0 0.
1 0 0.
Potential energy X Y.
X Y.
Yes.
X square. Omega naught square.
X Y.
Minus alpha. Minus alpha.
Alpha by 2. Minus
Then
alpha 2.
X Y.
तुम्हाला मार्क कशाला आहेत? फक्त एवढ्याच फक्त व्यवस्थित लिहिलेला मार्क आहे. दॅट्स इट. हाऊ मच?
Alpha येईल सर.
X
2 नाही आहे ना.
alpha. Only alpha.
Alpha येईल. Only alpha. Minus alpha. Sorry.
Oh.
तर अल्फा बाय 2 कसं येईल? ते हाफ बाहेर आहे का? ब्रॅकेटच्या बाहेर आहे का?
Yes, this is only for first part.
पण 2 बाहेर घेतलं सर आपण
Yes,
potential
sir.
नाही ना, हा ब्रॅकेट काय घेतलं? मग हे ब्रॅकेट आतमध्ये घेतलं असतं.
एनर्जीचं.
हा कंस जर इकडे असता तर मग तिथं आपल्याला 1/2 सगळ्यांसाठी कॉमन आलं असतं. येतंय का लक्षात की नाही?
नाही sir.
Okay, so here we can divide by
नाही सर.
1 minute.
तर ब्रॅकेट टाका ना.
Now, sorry. Minus alpha xy can be written as minus 2 times alpha xy upon 2
X Y.
minus 1 by 2. Sorry, plus 1 by 2.
Alpha X. Minus alpha X Y.
Got it?
Yes sir.
Okay. Omega naught square minus alpha omega naught square minus omega square 1 0 0 1. Okay. omega naught square minus omega square minus alpha omega naught square is equal to 0. Omega naught square minus omega square, 0 non-zero.
Square non-zero.
Non-zero.
Why this is equal, no, is not equal to 0?
Equal नहीं.
का equal नहीं दोनों. These two terms are not equal. Why?
0 square.
Here omega naught square is not a frequency. Here omega naught is not a frequency. This omega naught is a constant. Omega naught is a constant. This omega is a frequency. Omega naught square minus omega square bracket square minus alpha square is equal to 0.
0.
Omega naught square minus omega square minus alpha is equal to 0. Net 5 marks problem. Net 5 marks. This is one is a two frequencies. First frequency omega naught square minus alpha square, and second frequency
Omega naught square plus alpha square.
alpha square. Yes, any doubt in this case?
No sir.
Next. Three-D system. Suppose Alec L is equal to 1 by 2 m x dot square plus y dot square plus z dot square. 1 by 2 m or t is equal to 1 by 2 m x dot square plus y dot square plus z dot square, and potential energy is equal to 1 by 2 m omega square 1 by 2 m omega square three x square plus 3y square 3x square plus 3y square plus 2z square plus 2z square plus 2xy plus 2xy. Kinetic energy T
X.
0
Zero.
What y dot z?
potential energy 3
3 0 1. 0
2 times xy can be written as 2 times xy
1.
x plus y.
X1. 1.
X y plus y.
1. 0.
find out first. We getting how many frequencies?
Equal to
Omega 1
3 frequencies.
omega 2 omega
sir m omega square पण घ्यावं लागेल. कायनेटिक तर m omega square पण घ्यावं लागेल ना पोटेन्शियल एनर्जी मध्ये. m omega square की हां.
yes m omega square 1 minute घ्यावं लागेल ना.
बाहेर कॉमन घेतलं तरी चालेल ना सर?
ओके बाहेर घेतलं तरी चालेल. ओके
m omega 3 m omega square sir.
सर एम ओमेगा स्क्वायर इज के, तो के भी लिख सकते हैं.
घ्या एम ओमेगा स्क्वेअर कॉमन घ्या. एम ओमेगा स्क्वेअर कॉमन घेतलं नाही. टी तर एम घेता येईल दुसऱ्या केस मधून.
ना लिहिता नाही येणार का?
वी मधून एम ओमेगा स्क्वेअर कॉमन घ्या. and t can be written as m 1 0 0 0 1 0 0 0 right on. and m omega square 3 1 0 1 3 0 0 0 2 first. Now system is circular. There is a two particles, okay? Two particles, okay? What is the kinetic energy? How many particles? Two particles. One particle in the direction, another particle in the direction. First velocity, x1 dot. Second velocity, x2 dot, okay? Then kinetic energy T is equal to 1 by 2 m 1 by 2 m x1 dot square plus x2 dot square. Okay, potential energy. Here potential energy is the elastic potential energy. Elastic potential energy. First one. Here first displacement is x1, second displacement is x2. Means 1 by 2 k x2 minus x1 bracket square plus second one 1 by 2 k. First displacement, this direction, displacement x1, this direction, x displacement x2. For second spring, displacement
x1 minus x2.
first case, initial x1, final x2. Second spring, initial
x2.
Final
x2. Initial x1. Final x1.
Final x1. Okay, means here is a x1 minus x2 bracket square. Got it? x1 minus x2 bracket square. System is circular. Circular radius r, making angle theta. Initial displacement x1. Second displacement x2. Angle theta 2. Radius.
Theta.
Okay, means theta is equal to x1 upon theta 1 is equal to x1 upon r. Theta 2 is equal to x2 upon r. Means x1 is equal to r theta 1. x2 is equal to r theta 2. x1 dot is equal to x1 dot
r theta dot 1.
r theta 1 dot. x2 dot
r 2.
means kinetic energy T is equal to 1 by 2 m r square theta 1 dot square plus theta 2 dot square. Okay, means x is converted in the form of x1 is equal to r theta 1, x1 dot is equal to r theta 1 dot square. Got it? Potential energy 1 by 2 k r square yes.
सर नहीं समझ में.
कौन सा समझ में नहीं आ गया?
सर वो
यस क्या समझ में नहीं?
x2 minus x1 और यहाँ x1 minus x2.
ये हमारे पास सर्कल है, ठीक है. फर्स्ट पार्टिकल इज हियर, सेकंड पार्टिकल इज हियर. दिस पार्टिकल मूविंग इन दिस डायरेक्शन. ओके, डिस्प्लेसमेंट x1. ओके, this particle moving in this direction, displacement x2. Okay, this particle is shifted here. Okay, my displacement x1, this displacement is x2. Particle 1, particle 2. Okay, we consider this one is a displacement. Okay, general, suppose this one is a spring. This displacement is x1, this displacement is x2. How to find out this? Expansion or compression? x2 minus x1. Here this is initial, this one is final, means final minus initial. Final minus initial means what is the actual displacement here? x2 minus x1. x2 minus x1. Now consider the second case. Here also one spring. Here also one spring going in sequentially. This one is a sequence. Now we consider this spring. This spring at that time, this one is initial, final. Suppose here is a two spring, then this one is initial, this one is final. Next, x2, x3, x2, x3. At that time, x2 is, for this case, x2 initial, x3 final. Similarly, here x1 final, x2 initial. x1 minus x2. Got it? ये बेंड कर दिया, ये सर्कल हो जाएगा. ओके, दिस इज लाइक दैट. x2 minus x1, x3 minus x2, but x3 is nothing but coincide with this one, means x1 minus x2.
सर पोटेन्शियल एनर्जी मध्ये कसं आलं ते नाही कळलं. r2.
ओके, हाँ, पोटेंशियल एनर्जी 1/2 x2. x2 वैल्यू इज इक्वल टू r थीटा 2. x1 is equal to r theta 1. x1 is equal to r theta 1. x2 r theta 2. We can substitute x2. x2 is equal to r theta 2. Means this is equal to theta 2 square minus theta 1 square. Plus similarly here also 1/2 k r square. 1/2 k r square.
तर theta 1 minus theta 1 the whole square.
Okay, हाँ. Theta 1 minus theta 2 bracket square plus 1/2 k r square. Theta 2 minus theta 1 bracket square. Okay. This can be written as theta 1 square plus theta 2 square minus theta 1 theta 2 minus theta 2 theta 1 plus theta 1 square plus theta 2 square minus theta 1 theta 2 minus theta 2 theta 1. Kinetic energy.
theta 1, theta 2.
Kinetic energy T.
Theta dot 1.
Kinetic energy T. M 0 M. Potential energy 1 1 2. Two kr square. Theta 1 theta 2. Theta 2 theta 1. How many times?
Theta 1, theta 2 times.
R square also we can take common out.
2k. 2k dissolves.
1 2.
No, theta 2 square. Theta 2 square. 2k.
Okay. Omega square m 0 0 m. First frequency omega 1.
0.
Why omega 1 is equal to 0?
Spring is a rest, the
We need to consider one particle is a reference. Reference particle at a rest. Yes or no? Reference particle at a rest means omega 1 0, omega 2 under root 4k upon m, under root 4k upon m. Two particle, first frequency 0, second frequency.
0.
Yes, any doubt in this case? Yes, Ola.
Wait, sir.
Now we consider the three particles. Three particles, frequency, three particle, we're getting how many frequencies?
3 frequencies.
Three frequency. Out of three, one frequency.
Frequency 0. Nothing by 0.
One frequency, 0. Omega 2, omega 3, non-zero. We're getting some values. Yes or no? Now three particles, kinetic energy.
Sir, 1 minute down. Take down.
बोला omega.
Please, Ajadi, take it.
First particle, kinetic.
1 minute of fun, sir.
Here is how many particles? Three particles. Three particle, kinetic energy 1 by 2 m. 1 by 2 m. x1 dot square plus
x1 square plus
x2 dot square
plus x2
x3
plus
dot
x3 dot square.
potential energy 1 by 2 1 half k
x2 minus x1 whole square
plus
then x3 minus x3
x3 minus x2 bracket square plus
x3 minus x1.
x1 minus x3
Yes, sir.
x1 minus x3 and हे लक्षात आलं for circular case circular theta is equal to angular displacement. Now here we consider the three particles okay, three particles first second third okay. Yes, first displacement x1, second displacement x2, third displacement x3 okay. Velocity x1 dot, velocity x2 dot, velocity x3 dot, displacement, first displacement
x2 minus x1.
1 2 3, x2 minus x1, second displacement
x3 minus x1.
this
x1
displacement
minus x3.
x1 minus x3.
Minus x3.
Yes or no? This one is initial, this is final. This final, this one is initial. This is initial, this one is final.
Final minus initial.
T 1 by 2 m x1 dot square plus x2 dot square plus x3 dot square. Okay? Or 1 by 2 m r square. 1 by 2 m r square. Yes. Theta 1 dot square plus theta 2 dot square plus theta 3 dot square. So, potential energy 1 half kr square, 1 half kr square. Yes, inside the bracket theta 1 minus theta 2 bracket square plus theta 2 theta 3 minus theta 2 bracket square plus theta 2 minus theta 1 theta 3 minus theta 2 bracket square theta 1 minus theta 3 bracket square. Here is how many particles? Total how many particles?
3 particles.
3 particles. Then total we getting how many frequencies?
3 frequencies.
Out of 3.
1 0. 0.
1
1 0.
1 0. 1 0. Okay. Next, second. How many particles? 2 particles. Okay. See a trick. This trick is applicable only for circular case. Suppose we consider the 2 particles. 2 particles, then total frequency. Total frequency omega square is equal to 2 into number of particles. 2 into number of particles. 2 into number of particles. 2 into number of particles into k by m. 2 into number of particles into k by m. Into k by m. Total number of particles 2. Into 2 into k by m. Got it? 2 into k by m. Is total frequency for 2 particles. One frequency always
0.
One frequency always 0. Yes or no? One frequency always 0. Why always 0? Because we need to consider one particle is a rest. Second, one frequency is equal to number of particle into k by m. Number of particle into k by m. Into k by m. Next, 3. Even number of particle distribution is even. Even number of particle.
The number of particles.
Even number of particle.
Of number.
Even frequencies. Odd number of particles. Odd frequency, like that. Odd frequency. See here. Measure remaining frequency. Okay. One frequency ki denar. One frequency. First frequency.
0.
Second frequency.
Number of particles into k by m.
Though 2 frequencies over. Next remaining. How to adjust this one? Even number of particles. Adjust the frequency in even number. Adjust the frequency in even number. Adjust the frequency in even number. Okay. Odd number of particle. Adjust the frequency in odd number. Okay. आता त्यामध्ये पहिली केस एक्सेप्शनल आहे पहा. 2 particle, 1 frequency. 2 particle, 1 frequency. 2 particle, total frequency. Total omega square is equal to how much? 4k upon m. 4k upon m. त्यामध्ये 1 frequency. Omega square 0. Second frequency 4k upon m. Got it? हे पहिल्या केस साठी. ओके. दुसऱ्यासाठी रूल प्रॉपर. नेक्स्ट 3 particles. 3 particle total frequency.
3 frequency. Out of 3, 1 is 0.
Total frequency.
Yeah.
2 into number of particle.
Particle and 2 k by m.
This is equal to how much? 6k by m. Means addition of all frequency is equal to how much? 6k by m. Omega 1.
0.
Omega 2.
Omega 2. 3 odd.
Number of particles into k by m.
Just 2.
Number of particle 3 into k by m. Then what is the third frequency? Third frequency total 6.
3k by m.
3k upon m.
K by m. 2k.
3k by m. Got it? Total here 0 plus 3. 3 झालं. Remaining 3 is the 3k by m. Next 4 particle. 4 particle, omega 1. Omega 1,
omega 1,
omega 2, number of particle into k by m.
4k by m.
Omega 3, omega 4, adjust such that here even number of particles, adjust the even number.
2k by m.
Okay, right? High number of particles. Omega 1,
Omega 1 is equal to
omega 2,
omega 2 by m.
omega 3, omega 4, omega 5.
311. 3k by m, k by m आणि k by m.
This is 5. Okay. 5 is over. Sorry. म्हणजे total frequency 10. 10 k by m. Yes or no? Number of particle into 2 into k by m. Means total 10. 5 plus 0, 5. Means remaining is 5. Adjust such that we are getting odd number. Odd number. Yes.
311. 311.
3k by m.
3k by
K by m. K by m. Okay.
k.
तर ओमेगा 3 कसं आलं काय ओमेगा ते नाही कळलं सर.
Omega 3.
तर 4 पार्टिकल आणि 5 पार्टिकल्स एकदा सांगा ना.
4 particle is a even number. मग किती झाले? 4 झाले frequency. Total किती येईल? 8k येईल. Yes or no? What is the remaining frequency? 4k. 4k by m. How to 4k adjust in the form of omega 3 and omega 4 because here this one is even means this must be even. मग 4 ला आपल्याला 2 मध्ये कन्वर्ट करायचं. 1 3 पण चालेल, 3 1 पण चालेल, but 3 and 1 is not a even number. म्हणजे ते घेता येणार नाही. Next, other possibility 0 and 4, 4 0. But second remaining frequency is not equal to 0. Only one frequency is equal to 0. Yes or no? Means 0 4 4 0 combination also not allowed.
Possible.
Oh, okay. Means only possibility is 2 2. That's it. Next, 5 particles. Total frequency 10. Out of 10, omega 1 0, omega 2 5k by m. What is the remaining? 5k by 2. 5k by m. Adjust 5k by m such that here number is odd. म्हणजे 3 मध्ये कन्वर्ट झालं पाहिजे आणि ते टोटली तीनही नंबर ऑड आले पाहिजेत. तुम्ही असं केलं तर 2 2 1 पण चालेल, बट 2 2 इज अ इवन नंबर. मीन्स इवन नंबर इज नॉट अलाउड इन ऑड नंबर ऑफ पार्टिकल्स. मीन्स ओनली वन पॉसिबल कॉम्बिनेशन इज देयर. दिस इज अ 3 1 1.
सर समजलं.
Next, eigenvector. Eigenvector v minus omega square t x is equal to 0. V minus omega square t into x is equal to how much? 0. Suppose matrix is a 2 by 2. Matrix is a 2 by 2 eigenvector. We can take xy or x1, x2, u, v, wx as you wish. Okay. 2 by 2 matrix. एखादा एक्झाम्पल सांगा. 2 by 2 मॅट्रिक्स. कायनेटिक एनर्जी T is equal to m0 0 m. ओके. पोटेन्शियल एनर्जी k minus k minus k k. Okay. At that time we getting omega 1 and omega 2. Omega 1, omega 2. नाही, दिस इज नॉट अ सर्क्युलर सिस्टम. आपण आयगन वेक्टर टॉपिक चाललाय आपला. सर्क्युलर सिस्टम ओव्हर. ओमेगा 1 आपण सॉल्व्ह केलं बघा एक एक्झाम्पल फर्स्ट मध्ये.
2m.
root k by
Root k by m, sir.
रूट k by
K
m
by m.
आणि ओमेगा 1 0 ना.
Yes, sir.
Okay. Find out the eigenvector or symmetric or asymmetric mode. Symmetric or asymmetric mode. What is the equation? V minus omega square t x is equal to 0. V k minus k minus k k minus omega square m 0 0 m x y is equal to how much? 0. X y is equal to 0. Okay. Then this is equal to how much? K minus m omega square minus k k minus m omega square xy is equal to how much? 0. Xy is equal to 0. Now we can substitute the 1 by 1 frequency. Suppose we can substitute omega 1. Omega 1 is equal to 0. Omega 1, first frequency, 0. Then this equation become k minus k k. Here xy is equal to how much? 0. Xy is equal to how much? 0. Means kx minus ky is equal to 0. K we can take common out. Means this become x minus y is equal to 0. Means y is equal to how much? Y is equal to x. Y is equal to x. Y is equal to x. We know that eigenvector x is equal to how much? xy. xy. We getting x, y is equal to how much? X value. Then this is equal to how much? xx. This is equal to xx. Now normalize this eigenvector. Then this become 1 by root 2, 1 by root 2, 1 1. Yes or no? 1 by root 2, 1 1. First omega we getting this one. We can substitute the omega 2. Omega 2 is equal to how much? Under root k upon m. Under root k upon m. Substitute here. Then this become k minus m omega square. Omega square k upon m. Minus k minus k minus k k minus m omega square. मला वाटतं 2k upon m असेल का? 2k upon m. X y is equal to 0. X y is equal to 0. Okay. This get cancel. This get cancel. Okay. K minus 2k minus k minus k minus k minus k. X y is equal to how much? 0. Means minus kx minus ky. Minus kx minus ky is equal to 0. Means minus x minus y is equal to 0. Means y is equal to how much? Minus x. Y is equal to minus x. Y is equal to minus x means
Capital Y equal to
y is equal to minus x. Okay. Means capital X is equal to x minus x. Normalize this waveform. Then this become 1 by root 2. 1 by root 2. 1 minus 1. Here we getting two eigenvector. First eigenvector 1 by root 2 1 1. And second eigenvector 1 by root 2 1 minus 1. Means here both are plus. Both are plus. Means the first particle in positive direction, second particle also in positive direction. Or minus 1 minus 1. Both particle. First particle also in negative direction, second particle also in negative direction. Got it? When we getting eigenvector is equal to 1 by root 2 1 1. Here we getting 1 by root 2 1 plus 1 minus 1. Plus 1 minus 1 means first particle in positive direction, second particle in negative direction. First possibility. Or second possibility, first particle in negative direction, second particle in positive direction. Okay? Means this one is a symmetric mode or symmetric mode. Same direction, symmetric mode. Different direction, asymmetric mode. Got it? This direction, asymmetric mode. This direction, asymmetric mode. This direction, symmetric. This direction, symmetric. Means all sign getting plus or all sign getting minus, symmetric mode. Got it? Some plus, some minus. Some plus, some minus. Asymmetric mode. Suppose here we getting eigenvector x is equal to 1 1 1. Symmetric mode, asymmetric mode. Means this three particle in this direction or this three particle in this direction. Here this particle in this direction, second particle in this direction, third particle in this direction. Got it?
symmetric mode.
or first particle in, second particle in, third particle, like that. This one is symmetric mode. Symmetric, this one is asymmetric mode. Got it? Asymmetric. Yes, any doubt?